4.1, experimental probability. Now, first thing we should look at is reviewing fractions, because you're going to need to know how to get them back down to lowest terms. Take this first example here, 39 out of 117. Now, if you see a big number right off the bat that fits into both, in this case it's 39, you could skip right into that and lowers to 1/3. However, if you don't, try small numbers. Always check if they're both even numbers. Can you pull out 2s or 4s? Well, not in this case. Can you pull out 3s? Oh yes, you can. So if you don't see right off the bat a large number, greatest common factor, go with smaller numbers, and you can keep going until you run out of things to pull out. So this one here, I'm going to think about it as divide by 3, divide by 3. When I do that, this becomes 39 divided by 3, 13. 117 divided by 3, that's 39 actually. Then, you can fit a 13 out of each one of those. Divide by 13. Divide by 13. Of course, it'll take you a minute or two to think about what numbers work. Use your calculator, trial and error. You get 1 out of 3. Like I said, right off the bat, though, if you would have seen it, you could have just said, okay, yeah, 39 out of 117. Test that out with your calculator. Divide top and bottom by 39. And you will get 1/3. But you could do it either way. And I don't expect you to see it all in one step. How about 32 out of 48? Now with this one here, you could definitely tell 32 doesn't go into 48, so it's definitely not that. You could test out some other numbers. It's definitely an even number too. Would 4s fit into it? Yep. Would 8 fit into it? Yep, 8s do. 16 does as well. So you could have used a variety of small numbers and attacked it that way. However, if you see that 16 is the greatest common factor in each, go with that. Divide by 16 top and bottom, and you get 2 out of 3. Okay. Now, you'll have some questions to follow up on that. That's a skill you definitely need. Another skill you need is going back and forth between fractions, decimals, and percentages. Always remember that percentages are fractions, really, but they're out of 100. You just don't write it. That's what the little percent sign at the end means. I'm going to start with that one, the one that gives you a percentage. Think of it this way. If 12%, you should think, well, but doesn't that mean 12 out of 100? If I use my calculator, just hit 12 divided by 100, I'll get decimal 1/2. Now, that one you should be able to see that too. How do you get that into a fraction though? Smallest terms. Now this is where you're thinking, what fits into both 12 and 100? Well, 2 definitely does. Does 4? Yep, 4 does as well. So what I'm going to do, and I'm going to do the scratch work on the side, is I'm going to think, okay, divide by 4, divide by 4, and I get 3 out of 25. You can't reduce that one anymore. So there's the bottom one. How about this one here? I'll go with the 1/5. How do you get 1/5 as a decimal? If you don't know it, use your calculator. 1 divided by 5. You'll get decimal 2. Now, as a percentage, how do you go from a decimal to a percentage? I'll just show you something here and why it makes sense, and then you can just do it. Decimal 2 really means 2 out of 10. That's called the 10th position, right? Well, doesn't it make sense that that's really also 20 out of 10? Or 20 out of 100, my mistake. It's going to be 20%. I'm going to put 200 there. 20%. Essentially what it comes down to, though, is you take your decimal number and you multiply by 100. 100. Vice versa, if you wanted to go from, by the way, 12%, divide by 100, and you get the decimal 1-2. So it works both ways. Now that means decimal 70, that's 70 out of 100. Because I'll use this green. So that's going to be 70% multiplied by 100. Okay? Now the other way of going around, I'm going to do my scratch work here in green. So decimal 70 underneath I'm putting this is really 70 out of 100, we said. Let's reduce that by a factor of 10, or divide the top by 10, the bottom by 10, you got 7 out of 10. Can you reduce that anymore? Don't think so. So the fraction is 7 out of 10. Now you need to be able to go back and forth through those things. Some hints: to convert a fraction to a decimal, divide by the denominator. To convert a decimal to a percentage, multiply by 100. To convert a percentage to a fraction, put it out of 100 and simplify the lowest terms, okay? Now, next, working with experimental probability. Okay, let's think about some things as we read here. You might have heard some things like 8 out of 10 veterinarians recommend a certain brand of pet food. 8 out of 10, that's a fraction. Nothing to me. There's a 70% chance of rain today. That's 70 out of 100. 70 times out of 100 times that the day has conditions like this, there should be rain. There usually is rain. That's what that would mean. These are expressions of probability. Probability is a prediction of how likely it is that a particular event will happen. Probability could be expressed as a fraction, a decimal, or a percentage, or in words. We use the formula for calculating the probability, and we use a P usually, of an event A is, so we use probability of this thing A happening, is the number of times that it occurs over the total number of possibilities. Experimental probability is calculated based on measuring occurrences of A, whatever it is you're looking at, in a sample, or running a trial to find out how many times A occurs. Using the results of that sample or trial can help you make predictions about future occurrences. Now we'll see, because that P of A stuff is pretty abstract. Once you start doing this, it should make a little more sense, I would hope anyways. Georgina bought a bag of bulk candies, and she counted them and found there's 15 red, 10 green, 12 purple, 13 orange. This is where we're at. Now A, calculate the probability of a randomly chosen candy from the big bag being red. Express it as a fraction, a decimal, and a percentage, and in words. Now, first of all, we've got to figure out how many candies there are total. Even though that's not asked directly, we need that. Total candies before we even start. And that is our 15 red, 10 green, 12 purple, 13 orange. Okay. Add here 25, 35, 37, 50. Hopefully I'm not wrong. 50 candy. Yeah, I'm just thinking it through. Yep, 50. Now I'm ready to cook with gas here, get to the answers. The probability of a candy being red. So I'm going to put, instead of P of A, P of a red candy. Now remember, the formula is basically the number of red, in this case. Remember, I'm going back. What am I doing here? So the probability of something we call A occurring. In this case, the event is pulling a red candy. So the number of times you could have a red candy divided by the total number of candies. So in this case, it's the number of red, and it's the total number of candy on the bottom. So let's think this through here. Total number of red? 15 are red. And I added up the total number of candy would be 50. There's a fraction, but it's not in lowest terms. So the probability is, I can think through, I can divide a 3, divide by 3, divide by, no, I can't do that. I was thinking the opposite way around. I can divide by 5. Get through. Divide by 5, because that's 50. So the lowest fractions answer is going to be 15 divided by 5, it's 3. 15 divided by 5, 10. So 3/10. So we were supposed to calculate it as a fraction. Now a decimal. If you divide 3 by 10, you get decimal 3. And decimal 3 times 100 is 30%. And as it works, 3 out of 10. All those things in black mean the same thing. Now, what's the probability of a candy being green or purple? B. Probability of, I'm going to use green or purple. Now we have to figure out what's the total number of green and purple candies. 12 purple, 10 green, so 22 out of 50. Now, if I reduce that fraction, you get the answer. Those both reduced by 2, so the lowest terms is 11 out of 25. If you convert that to a decimal, you can use a calculator or think it through. It's decimal 44, which multiplied by 100 is 44%. And in words, it's 11 out of 25. Okay, now what? Distribution, if there's 1,000 candies, about the same. How many would you expect to be red? That's where the decimal comes in handy here. Remember, there's decimal 3 chance of something being red. So C, I would take your answer from A and say, well, the reds, decimal 3, take that probability answer from A, multiply it now by 1,000 candies. You're going to get 300 red candies. Why does that work? No. That works because this decimal 3 is really a fraction out of 1. If you say decimal 3 candies are red out of 1 total, which doesn't make sense, but multiplying wise works that way, and then you multiply it by 1,000. Because it would be no different than saying, well, 30 out of 100 candies are red. Take that decimal fraction and then multiply it by 100 if you're working with percentages. This just eliminates. When you take the decimal through right off the bat, it eliminates starting with the percentage, 30 out of 100 times 1,000. That's why that works, but enough of that. Let's just see if there's something else we need to try. Yeah, let's work the sample size here. Okay, so we'll read along here a little bit. When performing an experiment to calculate experimental probability, you need to consider the size, sample size, total number of objects or events being counted. A small sample size might not give you results that are representative of the whole population. When the sample size is appropriate, the probability of the event will be the same as the sample size is in the whole population as a whole. Here's a good example then. A large cafeteria serves lunch to more than 400 people per day and offers 4 main dishes. There we are, 400 people, 4 main dishes. Spaghetti, hamburger, chicken chow mein, vegetarian dish. Of the first 10 people through the line, no one chooses the vegetarian dish. The manager decides to remove the vegetarian dishes from the menu in the future. Is that a good decision? Explain your answer. Well, I won't write this up, but think about it. I'd say it isn't a good decision because there's probably some vegetarians in the lineup who want to eat from the cafeteria. They just didn't happen to be the first one that's lined up. 10 is a very small sample size compared to 400 students who would line up. Rather than eliminating that dish altogether, the manager should probably just keep track of how many total are sold in the day and plan your amounts accordingly. Okay, from there, I think you guys should be able to do the rest of the assignment here. Some more fractions, decimals, percentages, words, some word problems to try. I think you're set.